Assalamu alaikum. Today, inshallah, we are going to talk about the first chapter in physics. It's talking about the science of physics. So it's like an introduction. What are the fields that we are studying in physics? What about the scientific method of thinking? What are the things that we care about while we are doing any experiment or finding any law or theory and so on. So let's start by what's meant by physics. Okay, physics. What's meant by physics first? Physics means what? Physics, it means the science of nature. So you are studying everything around you. Okay, so let's talk about some topics that are found in physics and what are the names of the fields including these topics. So first, in physics, you can study mechanics. Mechanics means motion. So we are going to study the motion and its causes. What causes this motion? If it's a force or collision or anything. So we are going also to know the interaction between objects and how it causes motion. Like if you studied falling objects, friction, for example, as interaction between objects, weight, spinning objects, okay, and so on. All these are related to the field of mechanics. Then another field, thermodynamics. Thermo means heat. So in this field, you are going to study the heat and temperature, melting, freezing process, engines using thermal energy, and refrigerators, the cycle of cooling down anything, and so on. Coming to the next field, we have vibrations and wave phenomena. Vibrations are what? Repetitive motion. So we are going to study the repetitive motion, okay? Like the motion of springs, pendulum, and sound as a wave, light also as a wave, water or surface waves. All these are kinds of waves. Then the next field is optics. Optics, it's related to light, and we are going to study mirrors, lenses, some applications for mirrors and lenses, color, and astronomy. Then coming to the electromagnetism, it has two parts, electro and magnetism. So it's electricity and magnetism. They are highly related. They always come after each other. Why? Because we can produce electricity from magnetism and magnetism from electricity. So that's why they are always studied in the same field, electricity and magnetism. And light also, because light is considered as electromagnetic waves. So here in this part, we can study electrical charges, circuitry, permanent magnets, and electromagnets. For sure, those are some examples. They are not all the topics related to this field. Then coming to relativity. Relativity is what? Relativity is we are studying the motion of objects relative to each other. So particles moving at any speed, including very high speeds, like collision of objects, particle accelerators in nuclear energy, all these fields are found in relativity. Then coming to the quantum mechanics, the most interesting part for most of the students, it's talking about the behavior of submicroscopic particles. It's inside the atom in its parts. Okay, then let's move to the next part. What is a scientific method? Scientific method, as we know that there is no single procedure the scientists follow in their work. They are not following the same procedure, but they have common steps. All of them are doing through their scientific investigations. These common steps are called scientific method, okay? So the common steps together is called what? Scientific method. First, they start to make observations about something that they want to know about or search about. So they collect some data about these things and find some questions to find the answer for them at the end. Then they try to put some hypotheses. Hypothesis means some suggestions from the beginning. After that, they try to test these hypotheses by doing experiments. And after doing the experiment, they found some results. So they put the results and state a conclusion for what they have done. So here, let's have an example about this. Steps of scientific method. This is an example for it. We said we have first some observations, and we are going to put some questions or make some researches to find some questions that we want to search about or that we want to investigate. Then we are going to put an answer for this question, but it's not sure. So it's called hypothesis. Then we are going to test these hypotheses by doing experiment. And after that, we will have some results as conclusion. Okay? Because we will conclude what will happen in the experiments. So we will write down our results. And if we didn't get a sure answer or a final answer to our questions, we can make other hypotheses again and do experiments, and then have a conclusion. Then at the end, we will share our results with others. So as an example for scientific method, first we have here an observation that we observed that this plant has grown perfectly. Okay, so we want to find what is the result, what is the reason for growing well. So we have a question here. This is our question. This is the question that we want to answer by the end of the scientific method. Which type of fertilizer works the best? So this is our question. Okay, we have 3 types of fertilizers, A, B, and C. So we put a hypothesis that A is the best fertilizer for the plant to grow like this. After hypothesis comes what? Comes the experiment. So we are going to put the same the 3 fertilizers in the same plant. And we found that, yes, A was the best one. So we have a conclusion now that the hypothesis was proven correct. Our hypothesis was correct one, and A was the correct or the perfect fertilizer for our plant. So now we are going to share the results that fertilizer A is the best fertilizers among these for this type of plant. Okay, and this way we have used the scientific method. So scientific method is having 6 steps, 6 common steps. Okay, they are observations. First, we have observed the flower or the plant. Then we have made a research or put questions. What do we want to find? Then we have put hypothesis for this question. It means suggested answer for this question. And then we tested this hypothesis by doing an experiment. And after that, we concluded from this experiment. And then we have recorded our results to share with others. This is the scientific method of thinking. So most of the physicists, when they are trying to find any law or theory, they follow these steps. They have common steps, but not common procedure. Sometimes we use in our scientific method, okay, we use models. Models are often used to explain principles of physics. Okay, like what? Models like what? Let me show you the next slide. Okay, let's talk about the first thing, which is the model. The model may be a pattern, maybe a plan, maybe a representation, or maybe description. And they are designed to show the structure or working of an object, system, or concept. What do we mean by this? Here we have some examples as models. Sometimes we use a model for the solar system, like this one, to show how the Earth is rotating the sun and how the moon is rotating Earth. And here, for example, we use the model to explain how light refracts when it enters from air to water. So we used an example of the lawn mower. This lawn mower, when it enters from the land to the grass, it deviates in its direction, or as the light bends when it enters from air to water. And here, for example, in the forecast or weather, We sometimes use these models of different colors to show the direction of the wind, the storms, and the weather in different regions. And here in this example, we used a drawing to show the pattern or how the particles are aligned inside the salt particles. Okay, so here we have different ways. They are all designed to show the structure or the working of an object, system, or a concept. Okay, this is the first thing that we use is in a scientific method, which is model. Let's talk about the second thing, which is systems. Systems are defined to study the important components. What do we mean by this? If I have a situation like this, some people are playing basketball and a player throw the ball to the basket. And I would like to study the motion of the ball. And no one of these are going to touch the ball anymore. So I would like to study the situation completely and the projectile as a projectile motion example. Okay, this ball will thrown to the basket. So I would like to study the vertical and horizontal motion and to predict whether this ball is going to thrown inside the basket or out. So do I need all these people inside the picture? I don't need all these items. So I'm going to find out where is my system, because it's so complicated to study all these motions. I just need to define my system through this complicated situation. So I'm going to isolate what I need. I just need this player with his force acting on the ball and the curve or the path of the ball to the target. So in this way, I have defined my system so as to answer or to simplify the complicated situation. Let's go to the third point in scientific method, which is all experiments must be controlled. What do we mean by controlled? Limit the experiment to testing one factor at a time. Okay, let's take an example for this. For example, if I want to test the effect of pressure and temperature on the volume of gases, okay? If I change it both pressure and temperature together, okay, there may be an effect on the volume of gases. But could I know clearly now whether this was the effect because this effect was because of the pressure or because of the temperature? I couldn't identify which one causes this change in the volume of the gases. Or maybe their effects cancel each other, so I couldn't find any change in the volume of the gases. So in this case, I have to fix the temperature and only change the pressure so that I could know the effect of the pressure on the volume. Then I have to fix the pressure, no change in the pressure anymore, and I'm going to change the temperature this time. And I have fixed the pressure. So I'm going to change just the temperature. In this case, I could know the effect of the temperature on the volume of the gases. So this is called what? Controlled experiments. That you have to limit the experiment to testing one factor at a time. You couldn't test two factors at a time, okay? It won't be controlled and you couldn't have clear investigations. Okay, those are three important criteria used in scientific methods. Then let's talk about the next point. We said hypothesis means what? Hypothesis means it's a reasonable explanation for observations. We have observations or we have some questions. So we have put some hypotheses or possible answers for these questions, but we have to test these hypotheses to make sure that they are the real answers to our questions. Let's take an example for this. Galileo thought at the beginning he found objects falling to the ground, so he put a hypothesis saying that heavy objects fell more rapidly than light objects. So if I have a heavy brick and light brick, the heavy brick falls down rapidly more than the light object. But he have to test this hypothesis to make sure it's correct. So Galileo considered a situation, making an experiment. He tied the heavy object to the light object and let them fall down to the ground. Okay, in this case, for sure, the two bricks can fall faster or slower than the heavy brick. They are going to fall at the same time. So Galileo put another hypothesis that all objects fall at the same rate in the absence of air resistance. He put another hypothesis saying that both of them will fall down to the ground with the same rate. But for sure, we are assuming that there is no air resistance. So it's a perfect case. Okay, because some students are trying to, most of the students, when they are taking this part, they are trying to test it. Okay, teacher, let's do an experiment. I will throw this and I will throw this. This one reach it before the other. Okay, you are testing in the presence of air resistance, but here we are assuming there is no air resistance. Okay. Okay, so hypothesis means a reasonable explanation for observations. Let's talk about a very important point, which is the difference between scientific theory and scientific law. And this will be the last point in our lesson. Then we are going to answer some questions to test our understanding. First, what is the theory? Theory is the best explanation of observations and events. So first, I have observed something or I have seen something, and I'm going to put explanation for this, how it happened or why this happened, okay? So it's something complex more than the law. Okay, so I may have also several supported hypotheses. I may have several hypotheses, not only one. So what is the theory? How and why something happens. But coming to the law is a statement or equation. Okay, so it's not explanation, it's a statement or equation that reliably predicts patterns or events in nature. So it's considered universally true. We are not answering why questions. It's law that predicts what will happen. Okay, predicts through a pattern that will repeat itself. So it's usually based on one well-supported hypothesis that states that something will happen. Okay. Then let's have some questions to test our understanding for this part. I will read the question and I will give you some time to think of the answer. A scientist observed a bat, and after long thought, he discovered that bats are mammals. What do you call the work he did? Is it a theory? Is it conclusion? Or hypothesis? Or prediction? Okay. Here, a scientist observed a bat. Okay? He observed a bat. First, he has some observations. Then, after long thoughts means he put some hypothesis and think of the if the hypotheses are right or wrong, and so on. And he discovered that bats are mammals. So after some thought, he discovered the right answer to his questions or to his hypothesis. So this is considered as conclusion. He concluded that the bats are mammals. Okay, let's move to the next part. Next question. Okay. The scientific explanation of a natural phenomena based on observations and investigations over time is called, we are giving explanation. We are explaining natural phenomena. So this is, okay, yes, it's theory. It's the theory, but explain something, why this happened, how this happened. So it's theory. Okay. Next question. We can check whether the hypothesis is correct or not. By what? How do we check the hypothesis? Yeah, for sure, experimentation. We have to do experiments to test our hypothesis. Next one, the phrase the phrase, okay, the phrase, take care of this. Energy is neither created nor destroyed, but it changes from one form or transformed from one form to another. It's called what? The phrase, okay? We said a statement or a law. This is what? This is scientific law. Yes. The step after hypothesis is what? Again, the step after hypothesis, after we put some hypothesis or possible answers, what do we have to do? Yeah, we have to do experiments or experimentation to test these hypotheses. Okay. A testable explanation. What is a testable explanation? An explanation that will undergo tests, some tests, to test if it's true or not. Yes, this is hypothesis. We have finished our session for today. Thanks a lot, and I hope this was useful for you. And if you have any question, never hesitate to write it downward, and I'm going to answer it, inshallah, next time. Thanks so much.